In this video, we'll look at two examples of finding volumes of solids of revolutions generated by areas between two curves. We also call this the washer method, as the approximating volume resembles a washer. This video follows from the introduction of finding the solids of revolution, as well as a previous set of examples showing how we used the disk method of finding the volume of solids of revolution. Now, in our next example, our generating region in the Cartesian plane is bounded by y equals x and y equals x cubed. The axis of rotation is the x-axis. Now, you should pause this video here and try answering the problem on your own. And let's proceed. Let's plot a sketch of the bounds and the region and include an approximating rectangle of the area. This rectangle will generate a washer, which is a hollow cylinder. The volume of a hollow cylinder is given by pi multiplied to the quantity r sub capital O squared minus r sub capital I squared times the height of the cylinder. The outer radius is marked by the upper function y equals x, and the inner radius is marked by the lower function y equals x cubed. The volume of the approximating washer will be denoted by dV and is equal to pi times the quantity r sub capital O squared minus r sub capital I squared multiplied by the height of the washer, denoted by dx this time. Let's rewrite that with x and x cubed taking the place of r sub capital O and r sub capital I respectively. Then the volume of the solid of revolution is equal to the integral of dV, which is the definite integral of pi multiplied to the quantity x squared minus x to the sixth, evaluated from 0 to 1. Evaluating the integral will give us the antiderivative pi times the quantity x cubed over 3 minus x cubed over 7. Evaluating this again from 0 to 1, we have our volume to be equal to 4 over 21 pi cubic units. Now let's box our final answer and prepare to move on to the next item. Our next solid is generated by the region bounded by y equals the square root of x and y equals x over 2, which is then revolved about the y-axis. Now pause this video again to try to solve the problem on your own. And again, let's proceed. Since the region is to be rotated about the y-axis, the radius will be measured along the direction of the x-axis. So we have to write our boundary functions as functions of y. The outer radius is marked by y equals x over 2 and is equivalent to x equals 2 times y. And the inner radius, marked by y equals square root of x, is equivalent to x equals y squared. The height is given by dy. The differential volume is the volume of the approximating washer given by pi times the quantity r sub capital O squared minus r sub capital I squared times dy. And substituting the boundary equations to r sub capital O and r sub capital I, we'll have dV equals pi times the difference of the quantity 2y squared and the quantity y squared squared times dy. The volume of our solid of revolution is the integral of dV, or the definite integral of pi times the quantity 4y squared minus y to the fourth power, which will be evaluated from 0 to 2. This results in the antiderivative pi times the quantity 4 over 3y cubed minus y to the fifth over 5, evaluated from 0 to 2, which is equal to pi times the difference of 32 over 3 and 32 over 5, giving us our final answer of 64 over 15 pi cubic units, which we'll highlight as our final answer. And this ends our lesson for this video. Thanks for listening and see you on the next.